So this is the topic from where I have to start. Previously, we saw the set and set operations, and now it's a time for the functions. What is function? Function would be between two sets. Or if you have one set, then the function can be on itself. So anyhow, so if you have two sets A and B, if you have two sets A and B, then this is A and this is B. And for every elements of A, if you have exactly one element from this B, for every element of A, if you have exactly one element, for example, we have four elements. For this element number one, you have some element from B, exactly one. For element number two, you have one element from B. For example, element 3, you have some element from B. So if this will be the situation, that is called the function. And you can represent it with this notation, f of a is equal to b, which means that we are applying function on some element of set A and we are getting some element from B. Or you can write it in this way, function f colon A implies B, which means that we have the function from set A to set B and nothing else. This example will also give you the example. For example, this is the set A on the left hand side, and on the right hand side you have the set B. And you have these elements: Adams, Joe, or Jew, good friend, or Rodriguez, or Stevens, and you have the elements A, B, C, D, F here. So for Adams, you have one element from this set B, which is A. For Jew, you have one element from this one, exactly one. Good friend, you have this exactly one. Rodriguez, you have that exactly one. Stevens, you have exactly one. You don't have, for example, you have this one and also this one. So this condition is not existing. You have exactly one element from this B. So that is what you are calling a function. You can also call the function with another name, mappings and the transformation. These are also the other names. So now you can see that if you have two sets A and B, and if it would be the non-empty sets. If you have the empty, then there you have no relation. So that's why you have no elements for anything. So if it would be non-empty, then function is what? Function f. We can represent the function with f from A to B is an assignment. You have to assign exactly one element of B, exactly one element of B to each element of A. So this is what written here. Anyhow, moving forward, what is domain, codomain, and the image? It's easy. So if you have two sets, A and B, then this set A, the elements of set A is called the domain, and the elements of set B is called the codomain, and the elements which are directly assigned, directly connected, you can say, with the elements here, which are A, B, C, and F. This D is not connected. This D is not connected with the blue arrow, you can understand. So A, B, C, and F, these are called, these are called the image. This is called the image of A. Image of A. And what is, let's see. Yeah, we have these three terms. One term will come maybe next. So what is domain? Now I have given you the understanding. I don't know. So this is one approach. I can give you the understanding. Or other approach is I can say, okay, if you have the function, this function f, and you have the two sets now. Now we will get the whole understanding, detailed understanding. So now we want to get the understanding of this domain, codomain, and image. So now suppose we have some function which is f from A to B. When what is the domain? The domain of f. What is the domain of f? Domain of f, that is the A. If you have a function f for two sets A and B, what is the domain? The domain of this function f would be the set A, okay, which is written here. And the codomain of function f would be the set B, which is written here, okay. And we can assign one element from B to the element of A. So how we can apply the function over the elements of A? This is what the representation we have, f of A is equal to B. What it means? It means A is the element of set A, and if we have the function over it, and if you apply the definition of function over it, over the elements of A, then you will get some element from B. And B is what? According to our previous definition, it is the image. It is the image. The element that you are getting from set B is the image of the element of the set A. And A is what? It is a pre-image. Something before the image is called pre-image, nothing else, okay? An element before the image is called pre-image. And what is range or image? The range, so this is just a repetition. It would be the repetition. Range and image is the same thing, okay? Range and image is the same thing. But we can, normally range is giving a collective meaning. Range means something starts from here and ends here. Image is something giving a meaning that it is only one thing. So if you are getting one element from set B for an element of A, you can call it that B is the image of that. But if you will call that is the range of that element, that is also a K, but it is a little bit confusing. So you can also say that all elements of B that you are getting for the elements of A, that is called the range of F. Or you can call it image. Anyhow, it's the same thing. You can also say something like that, F maps A to B, which is this definition. F maps A to B. Okay. This is just these are the different terms that you have to understand, nothing else. This is just diagrammatically explanation that if you have the two sets A and the sets B in this circular shape, then this is the function you have. What is F? You can write F colon A implies B. This one. Or you can say F of A, then you have this B, and this is you are representing some element, single element. To understand F of A is equal to B, which is that one. To understand that one. So this figure is just a diagrammatical illustration, nothing else. So now you have now you know what is domain. Set A is domain. Codomain is what? Set B is. If we have the function from A to B, then set A is domain, set B is codomain, and the elements that you are getting from set B for elements of set A are called the image, or the range. Okay. Now moving on. What is the domain? So now I want to ask. On this slide, first I give you the definition. This is domain, codomain, and then On the second approach, I went through this stuff and gave you the understanding. Which one is better, the first one or the second one? The short one or the detailed one? Did you understand what I am asking? Both are okay. Which one I have to adopt? Both are okay because it's mathematics. Sometimes you cannot leave the things, especially for definitions. For definitions, you have to go into the detail. For problems, for questions, okay, you can just solve it in steps. Anyhow, it's okay. Moving on. What are the domain, codomain, and range of the function? And what is that? What is that function that assigns grade to the student? So you have the number of students in one set, and you have the number of grades in another set. You have to assign grades to the students. And what is the domain, codomain, and range of the function for this question? So this just a minute. So this diagram that you have here, these are the number of students, the names, and these are you have the grades. Now, what is the domain, codomain, and range? You know that. So this is what? Domain. This is what? Codomain. And what is the image? ABC, F. This is the image. And now we will have one more thing. Anyhow, so codomain is the whole B set, A, B, C, D, and F. D is one thing which was not assigned in that diagram, and range or image of G is what? A, B, C, and F, which are exactly assigned, which are exactly connected. Here, these are the connected, but this was not connected. So in the codomain, it is existing, but in the range, it is not existing. And there are examples from 2 to 5 in the textbook that you have to read it by yourself, okay? That would be the same. What is domain, codomain for different examples. And then the sum and the product. So if you have the two functions, for example, you can apply the concept of summing up two functions together, or you can apply the concept of product over the functions. For that, you must have two functions. So if you will have these two functions, f1 and f2, from set A to set R, and we are not given this information, what are these sets? We cannot say that this R is a real number because this is not given to us. So we have only two sets. So let f1 and f2 be the functions from set A to the set R. Walaikum assalam. So then what is the summation? You can write the summation into this form, f plus f2. And what is the product? F1 and f2. But this is just definition. This is not a question. I am saying what is actually, this is not. So this is just a definition. So f1 and f2 be the functions from A to R, and the information of these sets are not available. And the summation and product of functions from A to R would be that you will have the element x from belongs to A. You will have the elements x that will belong to set A. And then you will have the sum by this formula and the product by this formula. F1 plus F2 of x, and that x would be from set A. You will have F1 of x, you will have the value of F1 of x that will be given to you, and you will have the value F2 of x, that value will also be some function into the form of equation, into the form of some mathematical equation. Maybe F1 of x would be x squared plus 3, that would be given to you. We don't know. Okay, F1 of x plus F2 of x. So that would be the summation for this one. So you have to keep this formula in your mind. And F1 for product F1, F2 of X would be F1 of X multiplied with F2 of X. Now the problem is, now you have the example and then you will understand this definition. From this definition, you only have to keep these things in your mind, nothing else. You can leave the other things away. If you have these two formulas in your mind, then you can add, you can apply the summation, you can apply the operation of sum and the product for two functions between any sets. Anyhow, if you have the F1 and F2 from R to R, so now you have the one function itself, okay? You have one set R and you have to apply this F1 and F2, whatever it is, sum or product, R to itself. And F1 of X is given to you, which is X square, and F2 of X is given to you, which is X minus X square. So now what is the sum and the product? It is easy. Just write that formula F1 plus F2 of X. And then you have this formula. Put these values into the formula. For F1 of X, we have this value, F1 of X is X square, which you have just, and plus value for the F2, X1, X2, and this one minus and plus will be cancelled, and then you have only this X remaining. And similarly for product, you only have to multiply and you will have the answer. So it's a simple. So this is for sum and product. And now one-to-one. This is similar to the definition of function with a little bit restriction. Or you can say that is similar to the definition of the simple function that you have seen initially here. Exactly one element of P to each element. So a function, what is one? So now we are going to see one-to-one. Other name is injection, or you can also say injective function. One-to-one. This one-to-one is here acting as a noun, so you can say it is something injunction. So you can also call this one-to-one injunction or injective function. So these are the different things. So if here you have the set A and here you have the set B, and you are assigning the values from B to here, exactly one that you have seen the definition for this function here. Just keep that definition in your mind according to that example. I cannot assign same value from B I cannot assign same value from B to different domain elements. This is the only difference. Let's see, maybe, for example, here I am assigning this to Adams and also the Rodriguez. Rest of the definition is same. You have to assign some element from B to the elements of A. But you cannot assign this thing. Assign same value from B to different elements. This is the difference. If it is correct. If it is correct. If it would be wrong, some example will come. Because there is a little bit ambiguity in my mind. So that's why I'm saying the truth. When example will come, this will be clear. This is the only difference. Due to shortage of time, this ambiguity is in my mind. If I will prepare it at my bed, then those ambiguities will be removed. So that's why I didn't remove this sentence from here. So it is written here that some function never assign the same value from B to two different domain elements. Like the situation that I just showed you on that picture. So if these are the functions, then those functions are called one-to-one. So this kind of functions are called one-to-one. For example, here, this is normal, the definition of a function, but it is not one-to-one because the same value is assigned to two domain elements. This is domain and this is codomain. Okay. And now, here we have a function f, we can call it one-to-one or injunction, if and only if, this is the definition. If we have applied some, if we will apply, the domain will be given to us for some function. That domain would be the integers, the positive integers, or the negative integers, are like that. Like that. So the domain of function will be given to us. And then we have to take some value from that domain and we have to apply that function over it. And then we have to take another element from that domain, that would be B, and we have to apply the function over it. And that would be equal. That would be, implies that A is equal to B. If you have that situation, then it's also means that that is one-to-one other. But this definition is a little bit complicated. So this sentence is, that's why I didn't remove, and it is giving you the meaning of one-to-one, easy meaning, that you don't have to assign. For example, anyhow, here we have the function f of x is equal to x squared. And what is the domain? From the set of integers to the set of integers. So now you have the two functions from the set of integers to itself. You have, and the function is given to you, f of x is equal to x squared, and show that it is one-to-one or not. And how you can check? You have to check the domain values. You have to check the domain values. And here we are saying that it is not one-to-one because why? What is the reason? Because on when we take the value 1 and apply the function, which is x squared, and the x square of 1 is 1. And if we will take minus 1, and the x square of that minus 1 is 1. Again 1. So you have this A and you have this B, two values. You have this A and you have this B, two values. And if their result is same, this is also, you can mathematically conclude that for two elements A and B in the domain, you have the same value assigned from the. Now you keep this in your situation. Suppose that it is 1, it is minus 1, and you applied that function and you are getting 1. So that situation is now occurring. So this is not allowed. So that's why. So this duplication in the normal definition of function is allowed, but in the definition of one-to-one injunction, it is not allowed. It is not allowed. I hope now you will understand, huh? This is a sentence of Dr. Zakir Naik. Where it was. So So the A and the B, that is not equal, they are not equal, they are different elements from the domain. So we have checked different elements of the domain and we are getting same value for both of these elements for the domain. So that's why it is not 1 to 1. It should be different. It should have different domain values. You have different domain values and then you have the exactly different elements, not that thing. Some functions never assign the same value to different domain elements. That would really help you. Okay. Now, if you will restrict this domain only to Z plus, then it is 1 to 1. Okay. Then it is 1 to 1. You don't have the repetition because you removed that thing -1. Anyhow, moving next. I have time up to 3.
It's now.
Approximately now. Okay. Okay. These are just definitions. See them and keep them in your mind, and then maybe. Now we are going to see what is increasing, what is strictly increasing, what is decreasing, and what is strictly decreasing. So for increasing, if you have a function f and you have the domain of that function and the codomain. If you have the domain, you can understand there would be some two sets. Set A and set B. Set A is the domain, set B. You can take that picture, the initial introductory picture of atoms and grades are, you can take that picture in your mind and then you will understand. So if you have the function f and then you have the domain and the codomain, and if their domain and the codomain are subset of real numbers, now we have the domain actually real numbers and our functions domain and codomain, the values would be from the set of real numbers. And we can call that the function f would be increasing if this would be the situation. X, some elements on which you applied that function, and whatever the result you will get less than or equal to f of y, y would be another value on which you applied that function. So you are getting next value greater than previous value or equal. So that would be increasing situation. And what is strictly increasing? You only have, you don't have the equality strictly. So you have made strictly increasing, only increasing, no equality. So that's why you have removed that equality from this condition and nothing else. So that is the strictly increasing. Whenever, now you are explaining the values. Whenever you will have x, whenever you will have the next value y greater than x, and x and y are the values from the domain of f. You have two sets. This is domain. You are taking those values from here, applying the function over them. First you have taken the value x, you have applied function over x, you will get some value, result. Then you have taken the next value y, you applied the function over it, you will get some result. And now you are looking at them, that f of y is greater than f of x. If you are getting greater or equality, that is called increasing. If there is no equality, you are always getting greater, that is called strictly increasing. So this is what it is written here. And the opposite of this increasing is decreasing. Exactly opposite. And here you can say the next value is lesser than the previous value. Lesser or equal. This is called decreasing. And when you removed equality, then the next value is always lesser than the previous value. Okay, now you have, I think, the good understanding for these of two definitions. And what is on to or surjunction or surjective? It is the opposite of one to one. It is the opposite of one to one or injunction. So a function f, now you have the two sets A and B, and we have the function f. We can call it onto or surjunction if and only if for every element of B. Now you have to focus on the B, not from A to B. You have to focus on the B. For every element of B, there should be some element in A. So the condition is there is an element. There is an element, which means that one is also possible, more than one is also possible. There is not exactly one. You have to go with that definition. So you have to look over the elements of B. For every element of B, there is an element which belongs to A. So more than one is also possible according to the definition of the there exists. And how you can take f of A is f of A is equal to B is just giving you that idea. When you apply the function over A, you will have that B. Which means that for this B, you always have that FA on the reverse direction. You can say that I am considering, so this is the eighth element. This is the element from set A for that B. But you have to consider from B to A direction. Okay, this is also called surjective if it is on to. So now, okay, I am just stopping. You have the class next, all or no? You have. Okay, then I'm stopping. You have the class immediately after this class, or you have the gap between them?
Yeah, maybe 5 minutes.
Okay. Then it means there is no time. If it is only 5 minutes, huh? Okay. I think this is your class. We will resend it.